Yes, the volume was turned down somehow. Sorry about that. Anyway, so today we're going to have a look at user interfaces, or in particular how we are going to connect the back and the front bits. So I'll be doing first some lecture, and then we're going into PyCharm to actually have a look at Flask. There are some particular things in Flask that we might want to have a look at. So first of all, there was what we have been doing. So you might have, so this week you're also going to have you have already had a look at functions and exceptions, maybe a little bit files for those who are interested in that. It can be useful, but not mandatory. But so what we want to do now is having a look at actual event, so the user interface. So one of the key aspects we want to realize there is that when we are talking about user interfaces, we're almost always thinking about an event-driven process. Then we're going to look at how that looks with Flask, and then we're going to look at JSON and the data stuff. So what is this event-driven programming? And this is something that you need to get your head around. And basically, the thing is that in normal programs, imperative programs, what we do is we might define a function, and then we have an input that does this, but we control what happens at all time. We control the order in which things happen. For an event, in this case, so we have the function correct, and that takes a response, and it checks whether that response is the correct one. When we have a guess, we can say, okay, we can initialize that using an input. And then we can check whether it's correct or not. Obviously, this doesn't do any error correction. And then in the end, we print it. But what we need to realize is this is in order in which you can control things. When we are looking at UIs, and that includes JavaScript, by the way, where that happens the same way, you cannot control what happens when. The user does. And as such, you need to go to an event-driven approach. You don't get control, and it is something that many students struggle with also in the second year. How do you actually make sure that you have control in the thing? So like a UI, this is a UI that is in a language called, or a library called tkinter. It's not the prettiest, but yeah, there are some slides from last year that cover that. And there's and what you do is the user, normally you're just waiting for the user to do anything. What you're not doing is actually spinning a loop and say, okay, did the user do anything? Did the user do anything? No, you give back control to your framework, and the framework gives back control to the operating system, and the operating system just says, okay, until anything happens, I'm just letting you sleep. And then when the user does something, it sends an event to the operating system. So the operating system sends an event to the framework. The framework says, okay, what's happening? Oh, here, and there is some user code that needs to be executed. So, for example, with this kind of a framework, when you enter text, most of the time the user doesn't do anything about that. That's just going to be ignored. Only when you actually press the submit guess button, then user code will come in. Of course, you can hook in and do something when people enter text and stuff like that, but you don't need to. What we're talking about is basically a system where we have lots and lots of callbacks that handle our UI. So in the assignment, you're going to work with Flask. Flask, what is that? That is a web framework for Python that it includes, even mostly for testing purposes, but all that you need to do here a little web server, so you can just point your browser at it and then have a little web application written in Flask, and it can also serve up your file so that it works correctly. So the idea is what you're going to need to do is to basically take your web application, your front end that you have been working on already, and then add it to Flask. The way Flask works is that it has the ability to generate pages or content, but also to give you static content. Like your CSS files, your JavaScript file are just going to be served up by Flask without any modification. Of course, there's many of these frameworks, many of them in Python, and even more in any other language you can imagine. Some of them are Django or Web2Py. But yes, so we're just going to use Flask because it's fairly simple and straightforward. So how does Flask work in this structure? So Flask consists of a number of different parts, so to speak. So we have the library. This is the code that's already provided with you. That is run by Python. And through that library, it will actually allow you to respond to browser actions with some sort of response. Then it has the ability to have HTML templates. So you can actually have HTML documents where you can inject kind of data into it. So that's different from regular files in that it actually, when we have these templates, so regular files are not changed. These templates, they are actually allowed to be changed. There's also Python logic that is specific to you that you need to write. So the main thing you need to write is this Python logic and maybe an HTML template if you need that. Because you don't need that for your assignment. You can just write things that provide the JSON stuff. But if you want to make your page a little bit prettier and say, okay, you logged in at this particular time or something like that, you can. So how does this particular bit work? So in the end of the day, a Flask program is just a Python file. PyCharm actually has support for Flask, so you can create a Flask project all from scratch in Flask. But you don't have to do that, but it makes it easier. And you can use this virtual env system to basically make sure that it works anywhere and everywhere for your development. Where do you find your web page? Well, on localhost. Hopefully you remember from your networking that the special address 127.0.0.1 is special reserved address for the local machine named localhost. That name is also always mapped to this address by default. Yes, you can undo that and break lots and lots of stuff. Don't do that. But when we have our local host, we can then access this web server. One thing to remember is that it normally doesn't run on the port 80, the default HTTP port, but on another one. So you need to use a colon to specify the address. So how do you create a Flask application? Fairly simple. You create a variable, say app, say this is a Flask application with a particular name. You can also hard code your name if you want to. And then you say, okay, if we are in the main thing, then we run the Flask application. And that is how you can just run it. And yeah, you can configure it more if you want to, but you don't have to. Then we have the challenge of how are we doing routes. So how are we going to actually tell Flask where it needs to find what resources? And this is done through basically an annotation on a function. So when we look here, we see that we have the function welcome. And welcome, what it does, so this is the documentation of welcome. And this function just returns a button or a hyperlink in kind of partial HTML, I would say. And this is returned for the basically if you just have the top level URL. That's what this root says. And the root can just have URLs, but it can also have variable parameters in there. And the documentation also tells you exactly how to do that. So have a look at the documentation. That's very important. So this guessing page would then, for example, do guessing. So I've already added to the Brightspace the code for this guessing game, just as an example and a handhold for how you can get this going, so that you know something to start from. And I know it's not for this week for the exercise, but because we have a 3-week Easter break, it might make sense to have a go at it already amidst the Easter activities. So in this particular thing, what we see here in this function is that we have a global state. So we have this G, and then in that G we have this guess attribute that we set to empty. So we say, okay, before guessing we don't have a guess. And then we do this render template. The render template, what it does, it looks for this guessing.html file that we give as a parameter in the template directory, and then it basically goes through that template and it substitutes the relevant variables into that document. That way you can kind of mix and match your HTML with your Python code in hopefully the best way possible. And the G property is a special one that's available through Flask, so that it also becomes available to your template. So what does such a template look like? A template looks a little bit like this. So in this case we have a form, and there's a slide where it should have the full HTML tag, the title or the head and the title, and then the body, stuff like that. This kind of works, but it's a bit ugly. So what you can see here in this template is that we have the ability to substitute this guess variable. We saw that guess, okay, we put that as the value of the input. So if there's already a guess, we can reflect that again. And what we can also do, so if there is a message, we put that message in the parameter tag or paragraph tags. Yes, there's an empty tag there. And then we end this. So you can put quite some complex logic in there. This is what a template looks like in Flask. And kind of how you use Python logic in there. So data. So one of the things that you have is you want to often interact with data, and you can use your files for that as well. I think if you want to look at files and storing data for your app, that's a good idea, so that you can look at, okay, that's loaded in as JSON, and then provide that to your users, and then when you close your app you might store it again in the same file. So you might have static configuration of your thing, but sometimes you might want to actually configure it dynamically. So you can, for example, have data like this. Okay, we have different kinds of things that we have in our jars. We got an M&M jar, has certain image and has certain properties, etc. And you can of course do that in JSON as well. You can see that JSON is structured a little bit differently and works a little bit differently. than this Java, or this XML, sorry. You see in XML we have things like, we have tags everywhere, open and close, so it can get a little bit verbose in that sense. But it has certain properties that make it easy to handle as well, to have all those tags. And this is what JSON would look like. And when you look at a website, one of the things you are often going to see is that people try to optimize the data that they're doing, and they also don't want to. Okay, this is pretty printed JSON. That is very good for humans, but computers don't care. So a lot of times when people generate JSON, they don't do any of that, and they present you with something like this, which is basically all the white space left out, except the white space in the properties itself. So your programs will handle this just the same as if they're spaces, but it's a little bit more compact. Saves a tiny bit of data over the wire. Compression works really well. I wouldn't worry too much about the data over the wire, but people do that. So how can we use JSON? So you can do it for something like, okay, we want to have petitions. So this petition data by the government is actually open source. It's open access. You can actually get at the underlying data. So what they did, for example, in on this website, is to actually analyze this data and make this graph from it. And then you get data such as this. And yes, it's a little bit compact. But you can also have an application that says, okay, how many people in Bournemouth West did that? Or Bournemouth East did that? You get the idea. So, and in particular, what we also want to have the ability is in Python and in Flask is the ability to actually get our data. So what we want to do here is to check our program and then see, okay, we actually have this request object available to us where we can get the arguments of the request and then get this get property. So if you post something, it will be available as these arguments. You can then use that, set the guest from the argument, and then check whether it's correct, and we set the outcome. And then we set here in the template, we have this message property. Remember, the template had this message that it wanted to display if it had a value. This is how you do that. So you say, okay, message equals outcome in here. We have an additional parameter to our function. And that is basically the slides that we have left for Python, but we are going to have a look at how to make this actually work in Flask. And for that I need to switch to my other screen, and I will go to the challenge we have here is that we need to have a browser window as well. So I will open a browser window that we can then use to actually have a look at that. So let's first just run this task exercise. So what we can actually do is we can also just start. So no, it didn't work. So my configuration is a little bit different, and it wanted to install Flask and certain things at the wrong level, at an administrator level where it didn't have permission. So I'll leave it at this. But basically what you get at the start is basically almost like this. So this, so let me have a look. So we can appearance. We can go to presentation mode, and hopefully that should come up and give you a bigger screen. So this particular part where we have the test, that is not available, or not by default. It's the same thing with test.json. So what you want to do is you first have a number of static files that you have so we can have so if we look here, we see our project folder, and in this project folder we have these static files. So, and if you have a static file, you just use static file HTML. If you have your documents in a subfolder, you can say, okay, maybe I want to do something like everything that is so we might want to create a CSS file, or test.css, and we might want to use this to say, okay, for the yes, a very, very pretty style. Then we can go back to the application. We can then say, okay, app root CSS / file. Then we can dev send CSS and then we need to have a file parameter, obviously. And yes, you can see that because we didn't have that, it would actually warn us that this property does not exist. So one of the things you can, when you get this, yes, you can click on this this thing or press Alt-Enter. So I normally use the keyboard shortcuts because that makes your programming life a lot faster. And in this particular case, it says, okay, we can't really do anything against it, but it will still tell us what is the problem. It does not have a parameter file. Okay, we want the file. And then we return app.send static file. Let's see what this does. So we run this. We can, so in the run menu, so yes, I can get at it through a shortcut. Okay, I don't know where this favorite stuff comes from. Okay, there is something going wrong here. Okay. What is the error? Okay, URLs must start with a leading slash. Silly me. So we put that in there, and that should, oh yes, oh, reformat file. We need, so it will even get your style correct if you want to. So now what we can do is we can go to the web browser and open the, sorry, we first need to run it again. And it should hopefully also tell us where to listen to this. So we can take this URL. You can also click on it and open it in the browser. And then what we do now is we open it in our browser window. And then here we have Hello World. So if we want to do we want to make this different, that would work. Let's see if it automatically, no, so it doesn't automatically reload it. So we can now hopefully so now it's running again. So now we see hello application of programming principles. But we wanted to make sure that our CSS worked. So CSS/test.css. And we see our CSS file here having turned up. And we can also do so a test. So if we do something that doesn't exist, it should give us an error. So this is an easy way of getting all your CSS files hosted or your JavaScript. Or you can have basically what you can do is, okay, this is static. Your starting page should normally live at the root, so you need to do something special with that. So you can also do, okay, if you get the root, you can send a static file like test. So this is my static file. It's really boring. I can add a link to my background, and it will look really weird. Link. So, and then we have href equals css/test.css. Well equals style sheet, and this should just work. So we now do test.html. Oh, sorry, oops. Yes. Now you should see the code. If you give me a minute, what I can do is try to inject in some. I will make a way that I can put both of them on, or inject in the web browser. So let me have a quick look. And then I should also add the now we make it a lot smaller. It's something like 720. Top right. Okay, so that doesn't work really. Okay, so I will just need to remember to switch. I think I'll do that. Just getting this set up now is a bit tricky. So anyway, we have this style file this way, and then we can actually load the test page, hopefully with the CSS file. So let's have a look at what this looks like. So I increased the size a little bit. So it lives in test.html. And this should reload immediately. Yes, we have our green file. So if yes, we want to change this, we can do it. We can make it yellow, or we can even, it's a cool tool, we can even say, okay, actually this color is really much better. So use the tools what they're good at. And now we reload. Oh, sorry. Yes. So I will show you the tool. So you have this color here. You can actually click on the color and say, okay, I want to have this, and then choose it. And the editor can do so web stuff. And this is what it then looks like. Well, it's probably cached. Yes. When we look at our thing, you can see that it actually, we have this get stuff and it doesn't reload it properly. So maybe if we tell, so we use a hard reload, yes, then we get the change. So you need to have a, if you press the shift and the reload button, it will reload it properly and it will not do this caching stuff. Because if you get a 300 something response, that means that it's either a redirect or in this case it's already in the cache, you don't need to reload it response. So yes, and it also favicon.ico is basically what is used to, so when we have this favicon bit here, this is used to put an icon on your web page. So if you create that location, that's where your browser will look for it. But let's have a look, a little bit of a further look. So what we have things like this JSON data. So we can have JSON data where we put this information. So so one of the ways that we can, so we can then say, okay, rather than doing it this way, we can say, okay, we want to get something like, so we can select this, duplicate it. So Control D is a duplicate, and we can say something like, okay, users/username. And then we have a username. And of course, that's a variable, not a string. And then we can have data that looks like this. So if we then reload, because we have to reload it to basically have this new code. Oh, what is wrong here? It is complaining like crazy. So, my users get user. It's probably complaining that the name is duplicate. Yes. So unfortunately, it is sometimes hard to get your data. So to make sense of these error messages, there's very little what we can do about this. So what does this look like now in a web page? In a web page, this basically looks, so we have our test page here. So we have users/John. And what it gives us now is this data structure. What we can see also is that this data structure is reversed from our Python. So if we look at Python, we see this data structure here as being user and then username and then the name. Obviously, this name is just hard coded here, but we could also have something like users is so we can have something like, So we can just make a dictionary. And then say John is John Vinny. And then we can use that. So we to basically then say, okay, name equal username. If it's none, we can say, we can do something like turn missing user. And we can do so. And there should also be, but I'm not that familiar with Python, unfortunately. Oh, with Flask, unfortunately. So, but there should be a way of, okay, we can not have these parentheses. And then we can just basically use the name here. And then we should be able to, after we rerun this again, we should be able to actually use this to look up users. So let's go back to the web page. And now we have our users John. And we get John Vinny. We go something like Jane. It says, oh, there is no such a key. So the dictionary says it doesn't exist. We should do this nice and prettier. So maybe put, so we'll fix this, but let's first check that if I put Paul in, my username in there. Yes, we get Paul. So how do we do this? How do we fix this? Well, one of the ways that we can do this is, well, so what we can do is to check if username in users, that should hopefully work. And then else, then we can put this. So let's see if this works, and otherwise we just have to do with a try catch, and that also works. And yes, 2 blank lines. So let's look at the web page now. It still works, and if I do put something else in there, it now tells us we have a missing user. So this is kind of how you can handle those things. You can set more properties. You can say, so when you look at, so you can see here, basically, if you have something that you want to say, okay, what is the parameters available? You can press Ctrl P, and it will give you the list of parameters. In this case, it is kind of a free-for-all, these star options. Maybe when we use Ctrl Q on this object, we can actually get the documentation. We see that it is fetching the documentation. There we are. It took a little bit. It's the first time I used that. So it will explain us how this works. So you're basically providing a rule and then options, so that you can then, and this basically transforms the function. And we can even then go out and open this web page if we want to for further explanations. And we can see on the web page that it is now loading. So, and I clicked it a few times too often. So this is how it works. So we have a root, so you can do things like, okay, to limit it to particular methods, for example. It also is a good way of getting to to look at how Flask works. So if we look at this documentation here, this is the API. We also have a lot of examples. So there's a tutorial of how to get started with this. So these are all, for example, all the parameters that Flask has. And we can see that Flask basically has a lot of things that you can configure it. Like, where does the templates folder live? What is the static folder? By default it has good values, so you don't want to really do anything about that. And so we can have things like, okay, one of the things we might want to see is how do we do responses? Let's have a look. How can we do responses? So yes, it has session support. We might want to actually use a response. So let's see if we can, rather than do missing user, we can have a should be able to handle your response. So let's have a look at that, because so when we look here, we can also just look at the user guide. That is probably the easiest way. So one of the things we want to do is handling errors in this case. So we can have a look at, so you want to look at request data. So sometimes you might want to look at which particular data there is. So in your method, you can have a method that checks from your request what is the method used. You can for example, use that to get our data. So what we might want to do is put in a parameter for something. You can have a CSS file that dynamically determines the color. We don't want to do that, and you need to be very careful with any user input that doesn't invalidate. So in our case, what we want to look at is how can we do these responses. So our responses is basically you can return a response object, but in this case we might want to just do it in an easier way. So what we should be able to do is use basically this approach. And yes, this is an error handler, but we don't need to use that in and of itself. So one of the things it also does, it automatically does this JSONification of Python dictionaries. You don't even need to do that manually. But let's have a look if we can make our application do the return missing user in a nicer way. If we put 404 there, which is the Python version or the HTTP version of not found, what does this look like? So Let's rerun this. And see what happens now in our web page if we actually do this again. We should now be able to see that this was actually passed along as an error when we use the inspector. So you should be able to developer tools should be able to tell us what is going on here. And so yes, we can see here it is that the server says it didn't exist. So we reload it again, just from a, or maybe we have poll. We put this in and we should be able to find, again, yes, it gave us a 404. So now we have the correct status message so that your other applications know that this is incorrect. Because as you know, the text messages mean very little for your application on the JavaScript side, but the status codes are very meaningful. Of course, this is a very sparse way of giving user information back. Hopefully this helps you a little bit in how you can get Flask going and how you can use the tool. So there's also things like handling file uploads, very important. If you have a especially you have a put request that is an upload, and you might want to handle those kind of things. There is cookie support. There's a lot of supports for many elements. So you can set error handlers, etc. So have a look at this quick start as well, and hopefully that helps you with getting going. So that is basically what I had on the demo. You obviously want to implement the API too, but let's see what we can have a little bit more today. Oh dear. That's the one we need. So are there any questions at this point? Otherwise, I might have a quick look at some other contents that I can get for you. That basically, one of the questions I got from Muse was, what do we do with this this business about classes? We didn't go a lot into classes, but classes are really important. And I might have a I might just take a lecture from the second year that I cover, just as a brief. So you might find some different code there, because it's that unit uses Kotlin, but I'll try to explain the code where and when it is there. So let me have a quick look at this lecture, because classes is a tricky concept. That, say, the tricky bit is not so much what is a class, but is how do you use that in a good way. So get rid of that. Hopefully we can keep it somewhat running nicely. So basically, this is from application programming, but classes are a key aspect of what you are doing. So basically what we're looking at with classes, so Python is a language that basically leaves all the types over to runtime, but that doesn't mean that there are no types, and you need to take that into account. But object orientation is a way of thinking about structuring your program. The idea is that you combine your data with the code that acts upon that data, and kind of, so should have this slide first. So that is what kind of object orientation is about, and it combines a number of different elements in this concept. So it is, a programming paradigm, but it also combines a number of things that you want to do in your programs. And at the same time, you may really need to realize that it does not do everything. Free functions, as you have been using up to now in Python, can be the right solution for what you want it to have. So it is not a silver bullet, so to speak, or a panacea, not a cure of all ills. If we had one of those at this moment. And it works well with certain kind of problems, and you may have seen that so when you look at Flask, it has objects. But object orientation is more than just using a dot notation to access a method that relates to that particular data. It is that, but it is also about organizing your data. So what makes up this this object orientation? So one of it is just the ability to structure your data, to have data that is related, so that belongs together, is structured together, and kind of is hidden away within your program, within a bit that, okay, only the code within this class will actually access this data directly. Everything else needs to go through this interface that can police this, can manage that. So that also leads to things like modularization, where you want to not put everything in one big file, and then it becomes a big mess and you don't know what to do with it. Now it can also use your code in a more flexible way, so to speak. There's code visibility. In Python, this is less important than with other languages, but you have the conventions where you use properties like with an underscore in there, so that it is clear to users that they shouldn't directly access this. And you have the property decorator to help you with that. Classes also really allow for code reuse. Of course, the easiest way of code reuse is just calling a method. The method is the code that you're going to reuse there. And an interesting aspect, and that is a key programming thing, is the idea of abstraction. To try to hide away complexity into a smaller part. You can do that with functions, but if you have data, you do that with objects or with abstract data types. So a data structure is basically just something where you group data together. It's fairly simple. And it is where you want to look at, okay, how does this data work together? How is this structured? An example of such a thing would be, and this is in Kotlin, a data class which has, so Kotlin is a typed language for the JVM, so it's an alternative to Java, so to speak. But such a data class, what it does, it basically holds all these values or variables, house, street, postcode, town, as strings. So you have to define the type when you define members of a class in Kotlin. You can also do that in another language such as C++. Let's skip this a little bit because this goes a little bit about what it looks like. For Python, that is a little bit over the top, not relevant at this point. But we're basically looking at a structure of data that is combined with elements. And yeah, skip that bit about references as well. I'll create a cut down version of the slide set for you that doesn't include all this after the fact. And this modularization is the idea of having things that group certain responsibilities close together and other parts not. So basically, if your particular code is not doing something, you do not want to actually expose it at that point either. And that is what modularization is about. So modularization in this case says, okay, I put this functionality in this class, and this class is the and everything else it uses that needs that access just uses this class and doesn't need to worry about how it's implemented. Of course, you also have files to group things and folders and stuff like that. And that's where Kotlin module or Python modules come in as well. So then is this abstraction stuff. So what is abstraction? Basically, abstraction is trying to kind of understand something by kind of having a more abstract, a model of it. You kind of look at it for what it is in a, if you kind of take away all the detail. And in programming, that means that we are going to basically have something that we say, okay, this is the way you can use it. This is the interface. This is what I give you to do. But we don't tell you necessarily how it is implemented. Now, if something is not particularly well documented, or if there's an error, it is very good to still have access to the source code. And it's often there for that particular purpose. But for normal day-to-day programming purposes, you don't need that. You don't need to look at how is this particular concept implemented. In Python, often the implementation is actually in binary code and not in Python, so then you cannot go and look at how it is actually implemented underwater. And how do we translate this then into our actual program? So one of the ways you do that is using for some abstract data type. So basically, this is what the Java interface is. But for Python, you don't have the separation between classes and interfaces, but you can still use this idea. And Python also uses something called duck typing. Duck typing is the idea that if it looks like a duck, it sounds like a duck, and it quacks like a duck, it is a duck. Basically, you just call the method that is supposed to be there, and if it is there, it will work. And if it's not there, it will not work. That makes for very easy coding, but it also means that you have less help from the compiler in finding your errors. But what you do is you basically say, okay, we only specify what can happen, what can you do with this data, rather than how does it work underwater. We don't really want to know about that in many cases. There are cases when you do need to know, because there might be speed implications for how it works, or memory implications, or other kind of implications that things. Or in the worst case, and please don't do this too much, is when you have code that you want to say, okay, I'm going to actually change this code, to say I need this system to do something that it's not supposed to do, and I'm going to look into the guts and see how I can actually kind of go around the intentional design and work with it. And then you need to look at the source code and how it actually works, and then hack around stuff. You sometimes can do that, and sometimes that's the only way in which you can do stuff. But it is also an approach that is very easy to break stuff. You don't necessarily want to do that. So one of the things you can do with this is very much that you don't want your user code to depend on the particular implementation, even if you write both yourself. Why? basically the problem if you depend on a particular implementation is that you are then going to be stuck to that particular implementation. You cannot change your mind, so to speak, for deciding I wanted to actually do this in a different way. You're then stuck with it. We don't necessarily want that, but that's what you get with if you put everything together. So if you have a larger program, you want to basically have different parts of the program only have a cursory understanding of what the other program does or how it works. You don't want to need to go into the details of another part just to be safely changing something. Because one of the things that you may not realize, but is a very important thing to in programming, is that programs in reality actually are much more often modified, updated, maintained than that they are written from scratch. I would say the vast majority of times when you start working in an actual job, especially if it's the actual job rather than a placement, you will be working with code that someone else has started. You will work with your entire team. So the idea is that you want to be able to think. So one of the aspects we're also talking is like when we're talking about there are aspects that need to be true for all implementations. This is called, by the way, the class invariant, something that never changes. This is often only visible through your documentation. So that is where, if you want to implement an interface or a class, you do need to read the documentation. Reading documentation is a key coding skill. You can't just say, oh, I'm trying how this works. You can a little bit, but it breaks very quickly, as you saw when I did the Flask bit. So, and it's also nice if you have these abstractions, you have these interfaces that you can document. Basically what you can say is, okay, if it works on the interface, it should work on all implementations. In Java you see it with the list types, etc. So, and we can even have multiple implementations that have multiple different strengths. Or if we're talking about databases, we have different database interfaces that are database interaction classes that work for different database types. In that case, it's obviously impossible to have the same code for the different databases. So we want to just have the same interface so that you can just strip out, okay, I have MySQL, I've got Postgres, I've got SQLite, etc. As long as your program only sticks within the subset of common SQL that is supported by all those databases, the rest should just work. Then when we have object orientation, we have this code reuse stuff. So what you want to really do all the time is reuse code. Make functions to wrap your code. Make classes to wrap common state and common behavior. Use inheritance if your classes if there's kind of common parent behavior beyond the individual behavior of the child classes. And object orientation provides some ways of doing this. But there's other ways, such as we can just use functions. Yes, the very always popular among students approach of copy-paste reuse. Copy-paste reuse is just asking for trouble because there are so many ways in which your code can break and you don't necessarily want to support all of that. But that's where copy-paste comes in. So normally if you're copy-paste editing something, and you're not editing it crazy like I just did with the method that I wanted to do for users. Of course, that's also example code. then you would have common code. So for example, when we looked at the documentation for Flask, we saw that they had like these error methods for handling there's no file. What you're doing there is basically saying, okay, we're going to not have every function do its own error message for file resource not found, but just doing it in a generic way. You have a consistent look and feel of your website, and if you want to change that look and feel or anything like that, it all works. You only need to change it once, and everything else that uses it, you don't even need to think about it. It automatically gets the new behavior. So templates. So code templates is something that is not in Java or in Python. In a way, the templates that Flask has are templates, but they're kind of different templates. They are output templates rather than code templates. Doesn't matter. The idea is sort of the same. You kind of have variation where you can then plug in different behaviors depending on the parameters you give. And it's also in a way that those decorators in Python work. Those decorators take some Python code and then do something with it, and then you get a new function as a result of that. Generics in Python, you do not need that because you don't need to use types. But generics are basically the idea of saying, okay, I want to have these containers that work with whatever you put into it. In Python, that always works because the types of variables are weak. Everything is basically whatever you put into it. Fully dynamic typing. Lambdas we didn't cover, and then we have things like inheritance. So what does inheritance do? So inheritance is basically when you have types, when you have things that you want to express that basically are variants of the same thing. So like if you have a UI, you have a concept of a particular widget or a view that you're displaying. And there's different kinds of widgets. There's text input widgets, there's buttons, there's labels, there is scroll panes, there's groups, there's radio buttons, many different kinds. But there's a lot of stuff that they have in common. For example, they all have a size, they have a location, they have a way of drawing themselves. That code can be shared by all of them. So what you do is you say, okay, they're all a particular view, then they are just a child or a descendant of that view. And in such a case, we can use inheritance. But remember, inheritance is a public relationship, also in Python. It is something that is visible. You can't just say, oh, I only need this behavior, but I don't want to be seen as if I am that. If you want to just take some of the behavior, some of the code of another class, but without promising to fulfill the contract that you need to fulfill as if you as if you are that particular class, because that's what inheritance is. Inheritance is a relationship where you are required to meet the contract of the parent. Everything that's true for the parent must be true for a child. So a common example is, for example, what if we have rectangles and squares? Can we use inheritance for rectangles or squares? So is a rectangle a particular square? In some ways you say, yes, a rectangle is a square. Math tells us it's a square. But if we use in programming concepts, that isn't exactly true. Why? In programming concept, when we have a rectangle, if we have a rectangle, if we have a proper rectangle, we might be able to change the dimensions, the width and the height. The square might also be able to change the dimensions, but of course its width and the height are the same, otherwise it wouldn't be a square. And so if we have a rectangle that happens to have equal width and height, it is conceptually a square, but not in terms of actual class. So we can't say, okay, a square is a rectangle, because a rectangle requires you to change one dimension and then not automatically change the other one. That's unexpected behavior for a rectangle. If we have a square, then so a rectangle obviously is not a square either, because a square we expect that the width and the height are always the same. So that is the challenge of the relationship. You must meet the contract of the parent, and sometimes things are not objects. And if you can't think about, okay, what is this object, or if you just say this is actually behavior, it isn't actually an object, or you can have an object that just wraps functionality, like the functor object, a function object. Basically, the only existence of it is that you can call something on it. In Java, you often end up creating those things, and in Kotlin or in Python, you do not need to. So inheritance is basically the idea that you reuse some of the implementation of a parent and the state, but that you in turn also promise to fulfill its contract. That's also where the strength of inheritance is that you can have different children and you don't need to know any of their details if you want to treat it like a parent instance. So a view framework, a UI framework, just says, okay, these are views. I just need to draw them. Oh, there is a mouse click pressed here. What do I need to do? I don't know. View, there's a mouse click. And then the particular view says, okay, I'm a button. I'm going to use this mouse click to do a button press. Oh, I'm a label. I'm ignoring this mouse click. Oh, I am an edit text. I use this mouse click to position the cursor in the edit thing and to get the focus to this particular control. So that way you can also very easily write your own controls, because the framework doesn't need to know about your control then, because your control is also a valid parent view or control that it knows about. But this is where inheritance and polymorphism comes in. The polymorphism is basically the idea that when you call a function, the actual function implementation you call, that is called, is determined by the type of the value that you're actually doing it on, not the type of the variable. In Python, obviously, variables don't have type; only values have types. But polymorphism is using that to determine the function to call. And in Python, if you have a free function and you pass it an object, again, that free function is determined not by the value, but by the context of calling it, which function is being called. And finally is code visibility, is the idea of actually hiding parts of your code. Let me have a quick look. And the idea is that makes your things easier to use. So yes, so there are some class principles that are very useful for you to know. And again, this concept is true whether it is Python or JavaScript or Java or Kotlin. So there is the class invariant. I already mentioned that. The class invariant is about making sure that there are things that just need to always be true for the entire class. Give me a minute. My battery is almost running out. These are really crappy rechargeable batteries. I should be back. Sorry about that. So the class invariant is basically the idea that certain things need to be true always for an object, for the class contract basically. And some of that is can be enforced in code, but a lot of that is also enforced in your documentation through users of your class, or especially inheritors of the class, reading the documentation and making sure it stays true. If you don't do that, you get really confusing behavior. So be aware of that. It needs to be clear. And one of the things that you might also say is there are sometimes classes have state. State can make something a little bit trickier, particularly if you not say, okay, this is a property that is just, I'm holding this property. But if you have state, like a network connection, that means that certain things cannot be called at certain times, which is a bit tricky, and you want to avoid that if you can, but you can't always avoid that. But what it does mean as a class invariant is that you normally want to make sure your objects are in a valid state as soon as the constructor is finished. And valid means that the class invariant is true. So the class invariant can be saying, okay, there are two states, there's an open file or a closed file, and when you start it will always have an open file or have a file that needs to be opened. So there's kind of starting a file, an open file, and a closed file that is now finished. Might be 3 states, and those 3 states have these properties and they should remain true. And you use your methods to make sure that is true, and that's why you also don't want other code to go in and look at your internal guts, so to speak, the internal functions or the internal properties, because then you cannot make this true. But the key part is that your constructor needs to make sure that everything is initialized and set correctly, so that invariant is true at that point in time. When we have inheritance, this is a relationship. Again, I already said so, but a child must follow the rules of the parent. You must always be able to treat a child like it is a parent. And yes, it's a public relationship. The other approach is something called composition. So that is basically the idea where you actually say, I has a relationship. So I have a property that holds this particular class. And you might just delegate functionality to that class to let it do its thing, but you then have full control and you cannot be treated as if you were an instance of that helper object, so to speak. So it gives you a lot more freedom to do that. Like I said, when you inherit a class or implement an interface, you promise to meet the contract. You can reuse shared code. You can also call parent code in a child code. Sometimes that's necessary. It's not always easy in a language to specify that is required. But documentation is really important there. Talked about polymorphism. Basically the idea that when you have an object of a particular type, that object determines what the actual implementation that is being called when you call a particular method. In duck typing, as Python uses, that is always true, because you just have an object and it has methods and you call that. It is not always true in other languages. In Java, it is basically true. In Kotlin, it is also basically true. But in a language like C++, you can actually also have functions that do not follow this rule. So you basically need to enable it for your specific functions. We will not go into that, how to make that work. So one of the tricks there is also to help with correctness. Things like Kotlin has an override keyword, because sometimes you need to make sure that when you override a functionality that the methods are actually compatible. So in Python you can't have multiple functions with the same name, so that's easier. Immutable type, so basically sometimes it is interesting to have objects that cannot change any values, just allow you to create new values with the same things. So that is basically classes, and let's put it to questions because I think other aspects of this lecture are really off topic here. So any questions? Please put them in the comments. I can do it in a nice and tidy way. So JSON, so getting JSON out of Flask. I think the easiest way of doing it is, so you can use, so when we looked at Flask, so we had this JSON, so what you can do is just return this Python dictionary literal, and that becomes a JSON object. But I wouldn't use a template to create a JSON. That just becomes yet another layer of indirection. So it is, so yes, you can look over those slides. I will provide the slide set. Obviously, I will also have the recording. The recording will be available, so you can look at it that way, but the slides will be also available as a PDF, so that you can look at them at that time. I will also put this slide, the other slides on Python there. So I might review the slides a little bit to make them slightly more applicable to Python, but I will have the slide sets available for you. So like this is, but anyway, so yes, so this is a way we can use JSON with our APIs. And you can also use JSONify to make it prettier. And there probably, if you go click on that and go to the documentation, it will tell you more about exactly what way which particular Python structure is going to be organized and what JSON it will produce. So you just look at the API that you have been given from the assignment, and then say, okay, how can I replicate that in Python? And then add some dynamic behavior, because in this case we can say, okay, we have this list of users. So we can do something like, why not do something like set user? Let's go quickly into presentation mode. So what we can do is to do something like, okay, so we want to get this, so let's have a look. So what we need to do is say, so yes, you look at the documentation, or an example in this case, so methods equals get. We want to have another method, let's say app.root test.json, or no, so I want not this one, I just want to get it from the get username. I want to so maybe we want to be able to create create a user. So what we want to do is users, and this one might be methods equals post. Yes, completion is really helpful there. So okay, yes, so dev create or set user, and we might want to see whether this works correctly. No, we need to get it out of the session, so we can't do this way. So what we need to do is to actually say, okay, user equals request.form. User, so I don't know why it's complaining about request, because it should be available. I know it's not important from Flask, so we better import it. So there's probably also make response, for example, we might want to use, not in this particular case. So yes, it's not imported, so now it should be there. Yes, the thing, the squiggly has now gone, and name equals request or name. And what we can then do is something like, okay, if user, or we don't even need to do it, user equals name. So this will help us to update, and then we basically return, okay, return user. And yes, we might want to move these users a little bit up so that it's visible. Here, but this should work correctly. And when we run this, we should then, yeah, we have to rerun it. And then we need to basically use a little tool to actually make these requests. So let's use Advanced REST Client. Okay, yes, there it is. It is loading. Yes, I was playing around with something else. So in this case, we just need to go, not that. You can make your all complicated requests. In this case, we don't need that here. Why is it going import? No, so let's just do HTTP //localhost 5000 /users / So when we do this, we can just use a get, and then we should be able to get some data. This is our data. We wanted to have the users, we want to post a new, so let me look at what is there. So let's look at Jane. Jane doesn't exist, so here we get the 404. But what if we want to have a Jane that actually does exist? So we can make it a post. We should be able to now go to without there, and what we should be able to do then is to have some properties, add a form parameter, and it was user Jane and you so name, so Jane Doe. Then when we send this, we should be able to get back. Okay, it returns. Okay, yes. It doesn't return our nice JSON, but it just returns our username as we set it. What we now need to be able to go back to the to the history, uses get, and then get Jane Doe, and no longer do we get an error. So this is how you can use some state. For your assignment, you do not need to persist your user data. You're allowed to, but you do not need to. So that's kind of the story of your user data. You do not need to persist it. Of course, it will give you. It is kind of an additional extra feature, but and I might look after the Easter break a little bit about how to do this in the Flask way, but because the slides are a little bit less time consuming than I thought it was, so this way I look at that today. But the main purpose is there. How can we support you for your assignment? So finally, I would say, please ask questions. We will be sort of around over the Easter period. We'll be having some breaks, but put questions in the virtual P201. If we can see if we can have new people, more people available if there's actually more demand for that. But do get started. Play around. If you get stuck, don't stay stuck. Ask questions in working hours. Use Piazza, use Teams, whatever you find works the best. And otherwise, if there's no any other questions, Okay, then I'll thank you, and I'll see you after Easter, hopefully in person. Okay, thank you very much.